We're going to continue on with our voltage divider here where I have 9 volts and then 2 resistors, and we're going to go over and do some calculations. So here is the circuit diagram that matches that wiring diagram, and notice that I have a 9 volt power supply and 2 resistors, each 1000 ohms each, and I'm going to call this resistor R1 and this resistor R2. Now in order to calculate the voltage at point VB, I need to figure out what the voltage is that is left to drop across R2. So in a series circuit, I start out with 9 volts, I stay at 9 volts, and then I drop some voltage across R1, and then whatever's left I drop across R2. So this voltage at VB has to be the same as what I drop across R2 because I need to get back to 0 on this side of the battery. So I have 0 volts all along here, right? I drop the voltage here, so I increase my voltage to that amount here. I increase my voltage again across here because I've dropped that voltage, so I get back to 9 here. So to calculate the voltage dropped across R2, I'm going to use Ohm's law, which is V equals IR. And if I want to figure out what the current is, my current is equal to V over R, where here my R is Req, and Req is R equivalent, and for a series circuit, my equivalent resistance, Req, is equal to R1 plus R2. So if I want to calculate the voltage across that's being dropped across R2, I need to take the current, this current, and multiply it by R2. So V2 is going to be, I said the current multiplied by R2. Oops. And I can rewrite that now. I can plug in here what I have here down here. So I can say V2 is equal to my I now is the starting voltage V over R equivalent. And for R equivalent I can plug in over R1 plus R2. That's my I. And then multiplied by R2. So rewriting that again, I have V2 is equal to the total voltage, that'd be 9 volts, times R1 over R1 plus R2. And notice now, so my voltage at 2, my voltage here that's dropped across R2, and that's what's at VB, is the total voltage times the ratio of, this should be R2, sorry, this should be R2 over the total equivalent resistance. So in this case, my V2 is going to be 9 volts times 1000 volts over 2000 volts. And so that just gives me 1/2 of 9 volts. So in this case, we'll have 4.5 volts.